Welcome to the Essential Guide on Statistics for Artificial Intelligence. If you've just finished learning about algebra and probability, statistics is your next crucial step. In AI, everything revolves around data, how we summarize it, measure patterns, quantify uncertainty, and evaluate model performance. Think of statistics as the language that lets machines learn from data. In fact, machine learning is essentially statistics, but automated and scaled up. Whether you're building a recommendation engine or detecting fraud, a solid grasp of statistics is what separates a good AI model from a great one. Let's dive into the practical concepts every AI learner must master. Before you can analyze or model anything, you need to know what kind of data you're working with. In AI, data comes in two main flavors, numerical and categorical. Numerical data can be continuous like temperature or price, or discrete like the number of clicks or purchases. Categorical data, on the other hand, includes binary types, such as yes or no, spam or not spam, and multiclass types like product categories or sentiment labels. Identifying the correct data type is crucial because AI models treat them differently. For example, you wouldn't use the same approach for predicting a price as you would for classifying an email as spam. Once you know your data types, the next step is to understand your data using descriptive statistics. The mean or average is calculated by dividing the sum of all values by the number of values. It's used in AI for feature normalization and as a baseline for predictions. The median is the middle value when data is sorted, making it robust against outliers, very useful when your data isn't perfectly clean. The mode is the most frequent value, especially handy for analyzing categorical features. These basic statistics are the foundation for any AI project, helping you get a feel for your data before you start building models. Beyond averages, AI needs to know how spread out the data is. The range, variance, and standard deviation all measure variability. Range is simply the difference between the largest and smallest values, but it's sensitive to outliers. Variance tells you how far data points are from the mean, while standard deviation is its square root, crucial for understanding uncertainty and detecting anomalies. Many AI models assume data follows a normal distribution, the classic bell curve, but real-world data is often skewed. Outliers like fraud transactions or sensor errors can seriously impact model quality, so AI systems must identify, transform, or flag them as anomalies. AI rarely works with entire populations. Instead, it learns from samples. Good sampling ensures reliable models, while poor sampling introduces bias. Correlation measures how two variables move together, ranging from -1 to 1, but remember, correlation does not mean causation. Covariance, a related concept, is used in advanced AI techniques like principal component analysis for feature reduction. When building AI models, it's vital to split your data into training, validation, and test sets, typically 70%, 15%, and 15%. This split helps prevent overfitting and measures how well your model generalizes. Finally, evaluation metrics like accuracy, precision, recall, F1 score, and mean squared error help you judge model performance. Choosing the right metric is more important than just chasing high accuracy. A core challenge in AI is balancing bias and variance. High bias means your model is too simple and misses important patterns, while high variance means it's too complex and overfits the data. The goal is to find the right balance for robust predictions. Statistics also helps quantify uncertainty through confidence intervals and risk measures. Professional AI systems always report confidence levels to indicate how reliable their predictions are. Mastering these statistical concepts, mean, variance, distributions, sampling, correlation, outliers, and evaluation metrics, will set you up for practical AI development. Remember, statistics is the bridge between raw data and intelligent learning.